Hello everyone, welcome to my second video lecture on numerical integration. In the previous video, we learnt about four important formulae of numerical integration, namely trapezoidal rule, Simpson's 1/3 rule, Simpson's 3/8 rule and Wedel's rule. Now we shall discuss the application of these formulae for evaluating the given definite integral. Let us consider the first example. Evaluate integral from 0 to 2 y with respect to x by Simpson's 1/3 rule. Given that the value of y at x is equal to 0 is 0.399, the value of y at x is equal to 0.5 is 0.352 and so on. So let us solve this problem. First we have to understand that in this problem, in this integral, the integrand has not been given explicitly. That is, the definition of integrand is not mentioned, but on the other hand, the table consisting of the value of the integrand at different values of the independent variable x has been given. So we shall use this table to evaluate the value of the given definite integral. So from this we come to know that x0 in this problem is 0, that is lower limit is x0, upper limit is xn. Now in this table, so the first value should be taken as x0, the second value should be taken as x1, x2, x3, x4. So we can say that n in this problem is 4 because the last value is having the subscript 4. Therefore here it is n equal to 4. Similarly, the value of y at x0 is to be taken as y0. So y0 is 0.399. So this value is y1. This value is y2, y3 and y4. Here the value of h we need, and we know that the difference of two consecutive values of x, either x1 minus x0 or x2 minus x1 or x3 minus x2, that can be taken as h. Therefore h is equal to, let us take x1 minus x0. So it is 0.5 minus 0 equals to 0.5. So we got the value of h. Now let us consider the Simpson's 1/3 rule. In the last video we have discussed about Simpson's 1/3 rule, and the same formula we are going to write here. So the given integral that can be taken as I equals to 1/3 means it is h by 3. So it is h by 3 into bracket the first value y0 plus the last value. What is the last value in the table? It is y4. So it is y0 plus y4 plus 4 times the y value with odd subscript. So it is y1, y3. In the present example, y1 and y3 are present. Let us write down them. Plus 2 times of the even subscripted values of y. It is y2, only one term in the bracket, because y4 that has already been taken over here. So the last term consists of only one value of y, that is y2. So this is the formula. In this formula, our duty here is to substitute the value of h, y0, y1 and so on and simplify. So let us write down the value of h here, that is 0.5 divided by 3 into the bracket. Value of y0 is 0.399, that is this value y0, plus the last value 0.054 plus the second term is 4 into bracket y1 is 0.352 plus y3 is 0.129 plus 2 times of y2, that is 2 times of 0.242. Close the bracket. Now our duty is to simplify the brackets. We can use the calculator and simplify the brackets. When we simplify the brackets, we will have 0.453. The value of this bracket is 0.453 plus 4 into this bracket, that is going to give you 1.924 plus 2 into this bracket is 0.484. So in the next step, let us add these three values, multiply by 0.5 and then divide by 3 to get the final value, that is 0.4768. This is the required value of the given integral, that is 0 to 2 of the integrand y with respect to x. The value of y have been specified in the table, and this is the required value of the given definite integral. So this is the solution of a very simple example, and this example has been asked in the previous year examination, that is 2019 examination for BSc final year students, that is BSc 6th semester students at Gulbarga University, Kalburgi, for 2 marks. So this is the solution of the first problem. Now let us move on to the second example, and the second example is evaluate integration from 0 to 1 divided by 1 plus x with respect to x by trapezoidal rule, and it is suggested here to take 8 subintervals of the interval of integration 0 to 1, that is the interval of integration. And after doing this job, we have to find an approximate value of log 2. So let us start the solution of this example. From this given integral, we come to know that the lower limit is 0. Therefore, that should be taken as x naught. The upper limit should be taken as xn, of course, xn. And it is suggested to consider 8 subintervals. Number of subintervals, we always know that it is to be taken as n. So in this problem, n is 8. So therefore this value is going to be x8. So the final value is x8. And now let us list out the data. What are the information we can collect from the data? Here x0 is the lower limit 0, xn, that is the upper limit, it is 1, and n has been given as 8. And of course the integrand is, we will take integrand as y, and in this problem it is 1 divided by 1 plus x. Now to calculate the value of h, we will use this fact. We know that xn is equal to x0 plus nh. So therefore it implies xn value is 1, that is equal to x0 value is 0, n is 8, h as it is. From this, h is 0.125, that is h is 1 divided by 8, which after simplification gives 0.125. Now let us write the trapezoidal rule. It is asked us to solve the given problem by using the trapezoidal rule. So let us write down what is the trapezoidal rule. It is very simple formula. The integral I, of course it is the given integral I, equals to half of the interval of differencing into the first value y0 plus the last value is yn. N is 8 here, therefore it should be y8 plus 2 times all the intermediate values, that is y1 plus y2 plus y3 plus y4 plus y5 plus y6 plus y7. So this is the trapezoidal rule, a very simple formula. Let us take it as equation number 1. Now our duty here is to find y0, y1, y2 and so on. x0 is 0 and we know the expression for y. By using that we can get the value of y0. y0 is of course 1 divided by 1 plus x0. Since y value is 1 divided by 1 plus x, y0 is 1 divided by 1 plus x0. So therefore it is 1 divided by 1 plus 0, it is 1. Similarly, we know that x1 is x0 plus h. It is 0 plus h value is 0.125. Therefore x1 is 0.125 and using that value we can compute y1. y1 is 1 divided by 1 plus x1. So you substitute the value of x1 equal to 0.125 here. So it is going to be 0.889 after simplification. Similarly, let us compute what is x2. x2 is x1 plus h. So it is 0.125 plus h value is again 0.125. It is going to be 0.25 and the value of y at that point x2 is to be taken as y2, that is equal to 1 divided by 1 plus x2 we shall write here, and this after simplification gives us the value 8 by substituting x2 is equal to 0.25. Similarly, x3 is x2 plus h, that is going to be 0.375. I am writing directly, and the value of y at that point, that is y3, is again 1 divided by 1 plus x3 after simplification gives 0.727. Now x4 is x3 plus h. It is going to be 0.5 and the value of y at that point is y4. y4 is 0.667. x5 is in the similar way 0.625 and that gives us the value of y5 as 1 divided by 1 plus x5 and it is 0.615. x6, which is going to be x5 plus h, therefore it is 0.75, and this after substituting in the expression of y gives us y6 equals to 0.571, and similarly x7 can be computed as 0.75 plus the value of h, that is going to be 0.875, and this value after substituting in the expression of y gives y7, as 0.533, and at the end it is x8. Of course, x7 plus h, 0.875 plus h value is 0.125, that gives us 1. So that implies y8 equal to 1 divided by 1 plus x8. It is 1 divided by 2, that is going to be 0.5. Now let us substitute all these values, y0, y1, y2 and so on, into the formula number 1. So therefore 1 implies the given integral 0 to 1 dx divided by 1 plus x equals 0.125, the value of h I am writing, divided by 2 into the first value plus the last value, that is 1 plus 0.5 plus 2 times of all the intermediate value, that is here to here, that is 0.889 plus 0.8 plus 0.727 plus 0.667 plus 0.615 plus 0.571 plus 0.533. So after simplifying this entire thing, that is these brackets are to be simplified and then multiply with 0.125 and divide the answer by 2 to get the final answer to be equal to 0.694. We can use our calculator to get the value of this definite integral equal to 0.694. So this is the solution of the first problem, that is the first part of the problem. We have evaluated the definite integral. Now it is asked to find the value of log 2. The approximate value of log 2 is to be found. To find the value of log 2, we have to consider the usual way of evaluating the integral. So we know that integration from 0 to 1 dx by 1 plus x, that is integration of 1 divided by 1 plus x is always log of 1 plus x. So the limits of integration are 0, the lower limit, 1, the upper limit. And from the previous example, from the previous computation, we come to know that the value of this thing is 0.694. So let us write this 0.694 here, and on RHS substitute the upper limit, log of 1 plus 1, it is log 2, of course base is e, plus log of 1 plus lower limit 0, sorry minus, we have to consider minus, so log of 1, so this implies 0.694 as it is on LHS, whereas on RHS log 2 as it is, and log 1 to any base is of course 0. So this gives us the value of log 2 equal to 0.694. So this is how we have computed the approximate value of log 2 using the trapezoidal rule. So in this way we can use the formulae of numerical integration to evaluate the definite integral. So we will work out few more examples on numerical integration. Therefore, please keep watching the next videos. Thank you very much.